for Friends of Science Society, coming to you live from Calgary, Alberta, Canada. And welcome to part 2 of Friends of Science Society's 17th annual event with Dr. Roy Spencer and the most important reasons why there is no climate emergency. Now, normally our annual events are held at the Red and White Club here in Calgary, and we normally have 2 speakers, one to address policy issues and one to address scientific issues. But of course, due to the pandemic last year, our event was canceled. And oddly enough, the event was called Freedom of Speech, No Climate Emergency. And these are 2 themes that have certainly risen in the public mind in the past year. So we had Donna Laframboise addressing freedom of speech on December the 8th. And if you are a member, you can still view that show anytime you want with your password. And tonight we're going to have part 2, which is Dr. Roy Spencer addressing the fact that there's no climate emergency. Now, Dr. Spencer is a NASA award-winning research scientist. He's a principal research scientist at the University of Alabama, Huntsville. And tonight he's going to explain why there's no climate emergency and how many of the things that we hear in the media are grossly exaggerated and what those exaggerations are. One of the great things that I loved about Dr. Spencer's pre-taped presentation is that he gives both the scientific information and a plain language interpretation. So even a non-scientist like myself can understand and really get a grip on what's going on in the world of climate change science. So with no further ado, let's roll the pre-recorded presentation in PowerPoint with Dr. Roy Spencer, the main reasons why there is no climate emergency, and we'll be back after that with Dr. Spencer live from Huntsville, Alabama, to answer your questions in live Q&A. And if we happen to run out of time with all your questions, what we propose is to do some kind of a blog post where you will be able to see answers to most of the questions that were sent in. So let's go on with the show. Dr. Roy Spencer, please roll the presentation.
Hello, I'm Dr. Roy Spencer, Principal Research Scientist at the University of Alabama in Huntsville. And as part of this Friends of Science presentation, today I'm going to be talking about the main reasons why I don't believe there is any sort of climate emergency or climate crisis, as they like to say, going on. This will be about a 30-minute talk, and I thank you for joining me. My talks are unscripted, although I will be using slides, and I prefer to do sort of informal talks where I feel like I'm sitting here talking to an individual person or to a group of people. So yeah, I'm very informal in my talks. So let's go ahead and get started here. As an overview, I want to make a few points. These are the things I'm going to be talking about in this talk. First of all, I do believe there has been slow warming. It's been occurring now for maybe 100 years, certainly in the last 50 years, but this warming has not been as fast as climate models have projected. Secondly, the cause of this warming is probably mostly from CO2, but we really don't know. Again, I'll go into details during my talk. Thirdly, most reports and predictions we hear about regarding climate change and global warming are exaggerated or wrong. That's just the way things happen in today's media, is, if it bleeds, it leads, so we only hear the most alarmist claims. Fourth, the cost of renewable energy, that is, what we could do about fossil fuels causing climate change. The cost of renewables is so high that physics, just basic physics, prevents us from being able to displace fossil fuels to any large extent with wind and solar energy. It's just not possible for any reasonable amount of cost. Anyway, and then finally, increasing CO2 also has benefits, and this is something that you don't often hear about in the media because good news really isn't news at all, is it? Next, let's talk about public perceptions. Obviously, there's a wide range of perceptions about climate change. Anywhere from it's a hoax to it's some sort of existential crisis, right? I'm at neither of these extremes. I'm considered a lukewarmer, which sometimes I get attacked. So sometimes I get attacked by both sides for not taking one side or the other. What am I fairly confident of in this debate? Well, as I mentioned, climate system has warmed. No question about that. This last decade from 2010 to 2019 was probably the warmest decade, at least in the instrumental record. This is an important point. We've only had thermometers around for 100 or 150 years. Secondly, at least some of this warming is due to increasing carbon dioxide. There are direct effects, warming effects of CO2 increasing in the atmosphere, and there are indirect effects. The direct effect, which is what we understand the best from basic physics, is only about 1 degree C for a doubling of atmospheric CO2, and we are only about half of the way, not even quite half of the way now in 2020, to doubling of atmospheric CO2 from pre-industrial times. And finally, I think that warming should continue into the future, somewhat slowly, as long as we're producing CO2 around the world. But I want to emphasize, none of these things are necessarily any cause for alarm, okay? So what is uncertain about this climate science, at least in my mind? Well, first of all, there are natural causes of climate change which really aren't understood. Climate can change without any kind of forcing. You don't have to have increasing greenhouse gases. You don't have to have a change in the sun. You don't have to have a change in the orbital characteristics of the Earth, because the climate system is a nonlinear dynamical system. That means that it can go through changes all by itself. For instance, I have this photo on this slide, retreating Alaska glaciers. This is the Mendenhall Glacier, which has been retreating for at least 100 years, and it's uncovering stumps of ancient trees, which were sheared off when this glacier advanced. And these trees have been carbon dated to about 1 to 2,000 years ago. Well, as you might know, 1 to 2,000 years ago tended to be a warm period based on a number of historical evidences that we have. And, this could have been the medieval warm period, the Roman warm period. Clearly, it was warm enough in this area of Alaska for at least hundreds of years. Okay, this can't be just a regional thing. It had to have been global. For hundreds of years to grow a mature forest before the glacier advanced again. So these climate changes occur, and climate models do not include these chaotic changes in the climate system. They're just not well understood. What else is uncertain? Well, the future strength of warming. How the climate system responds to the small warming influence from extra CO2 is really uncertain. The direct warming, as I mentioned, to doubling CO2 is only about 1 degree C, but the feedbacks, those are indirect effects of the warming, like how clouds change, greatly amplify the warming in the climate models. And that's what I don't believe actually exists in nature. There may be some small amplification, but I don't believe what occurs in the climate models, and these, even the climate modelers will admit, are very uncertain. And they amplify that 1 degree of direct warming to 3 or 4 degrees, okay? And even in the latest round of climate models, they're amplifying it even more. And these things are really uncertain. I mean, they sound alarming, but they're extremely uncertain. I personally believe, based on all the evidence I've seen, that maybe we will see 1.5 to 2 degrees C of warming as a direct response to a doubling of CO2. But it could be less than 1.5 degrees. We just don't know yet. Now, the CO2-caused global energy imbalance is tiny. What do I mean by global energy imbalance? Any temperature change is the result of an energy imbalance. The amount of energy coming in, the rate at which energy is coming in, and the rate at which energy is being lost. In the case of the climate system, that energy imbalance is presently only about 1 watt per square meter, averaged over the surface of the Earth. Now, our uncertainty in the natural energy flows in the climate system isn't any better than about 5 to 10 watts per square meter. We don't know from first principles or from satellite observations how large these energy fluxes are to better than about 5 or 10 watts per square meter. Now, what this means is that global warming could be mostly caused by natural processes, and we wouldn't even know it. Now, I'm not saying that's what I believe. I think that the warming is probably, at least that we've seen, is at least 50% due to increasing CO2, but that's nothing more than an educated guess on my part because there's no way to prove it. Now, the energy imbalance that causes temperature changes, this is a little bit of background. It occurs for everything, okay? This isn't something that you should feel intimidated by, the science of this. For instance, a pot of water on the stove. If you put a pot of water on a gas stove and turn the flame up to very low, the water will heat up, the temperature will rise as long as the energy gained is at a greater rate than the energy lost. Well, eventually that pot of water stops warming, doesn't it? Even though you've got this fire underneath it. Well, why does it stop warming? It's because the rate at which energy loss is lost by the pot to the surroundings becomes equal to the rate of energy gain, and that's when temperature change stops, okay? And this is true of anything you can think of, whether it's the inside of a heated and cooled house or a car engine or the human body, everything. Temperature change is a result of energy imbalance. This cartoon just shows this again for the climate system. And it's important to point out that these climate models are responding to this little tiny energy imbalance. It's only about 1 part in 300 of the global energy flows, this energy imbalance. The models are run such that they produce a considerable amount of warming, okay, just from this tiny energy imbalance. Well, how do they do that? How do they do that if we don't know the natural flows? Well, they adjust their models to begin with so that there is no energy imbalance. In other words, climate models are adjusted with the assumption that there is no natural climate change, okay? That's a major assumption, isn't it? Right? We've got about 240 watts per square meter coming into the climate system. That's what we think. It might be 235, 245. We really don't know. And that's the same amount goes out because we know global temperatures don't change by a whole lot on short time scales. So they adjust the climate model so that the energy in equals energy out when they run the climate model without extra CO2. And then when they add extra CO2, you get a certain amount of warming. Well, of course, you're going to get extra warming because they've assumed that the climate system is imbalanced to begin with. In this plot here on slide 9, I'm also showing recent warming of the deep ocean, which is measured in hundredths of a degree. So if you believe those hundredths of a degree sea warming in recent decades in the deep ocean, we can sort of estimate how much that energy imbalance is, and that's where that 1 watt comes from, is because we know how much energy is going into the ocean based on the fact that the oceans are very slowly warming by a certain amount. And as I mentioned, even our best satellites, radiation budget instruments on satellites as part of NASA's Earth observing program, they can't measure these levels of accuracy in energy flows. 5 to 10 watts per square meter is the limit of their accuracy. They really need to have an accuracy of maybe 0.2 of a watt per square meter before we can talk about causation in global warming being directly related to humans. Okay, climate models that supposedly prove humans are responsible use that circular reasoning. So the models are adjusted to produce no warming, then CO2 is added and warming occurs. And it thus concluded recent warming is due to increasing CO2. I really want to emphasize this. That's why I've got the summary slide. The models merely conclude what they assumed at the outset. Now, you might wonder about human fingerprints of global warming. Okay, you might have heard about that they think that we see the human fingerprints of global warming, therefore we know global warming is human caused. Well, there really aren't any human fingerprints of warming. Whether the warming is due to humans or nature, any source of warming will look about the same. Land will warm faster than the oceans. Warming will be the largest at high northern latitudes and the least at the far southern latitudes. This is what we see, is the North Polar region has warmed the most. There's been essentially no warming down around Antarctica in the last 100 years. And if they point to stratospheric cooling as a fingerprint, well, I do think that the stratospheric cooling we've been seeing is probably due to CO2. That's probably more certain than the warming down where we live in the troposphere being due to CO2. But I'd like to point out to people, stratospheric cooling is not evidence of warming. Okay, the stratosphere is much simpler. There's no clouds. There's no hydrologic cycle. And it's the clouds and things like that that really impact these feedbacks that will determine whether Mother Nature punishes us, in a sense, for putting extra CO2 in the atmosphere or not. Okay, now we've been doing some modeling to see exactly how much is the climate system telling us is going to occur in terms of warming as a result of doubling of atmospheric carbon dioxide. If we assume that all the warming that we're measuring is real, the hundredths of a degree in the deep ocean and the atmospheric and surface warming, if those measurements are accurate, what does it tell us about the sensitivity of the climate system? This is the equilibrium climate sensitivity, the ECS as it's called, which is how much warming you expect from a doubling of atmospheric CO2 once the climate system has finally come back into equilibrium, where energy gained equals energy lost. Well, we've published a 1D ocean model, one-dimensional. That means we just deal with energy flows vertically through the atmosphere into the ocean on a global basis. And this is an ocean-only, global ocean model, very simple, but it deals with basic physics, that is, energy flows and energy imbalances. And what we find in this plot, if you look at this plot that runs from 1850 until 2100, let's start with the actual sea surface temperature observations averaged over the globe. There, that purple curve shows how much it's warmed based on the best estimates from global temperature observations. Now, our 1D model, after we've adjusted it to match the energy flows that go along with what we see in the ocean warming and surface warming, sea surface temperature warming. That blue line there where it says 1D model, T-surface, that's how much we project the warming will happen in the past, and our model matches very well to past temperature changes back 50 to 100 years. And then that green line up above, that's the latest estimates of future warming from the climate modeling community, from the CMIP 6, the sixth review of the climate system done by the United Nations Intergovernmental Panel on Climate Change. And you can see that the green line, those climate models that the IPCC uses, does seem to agree with the observations. But if you look into the details, in the last 20 or 30 years, they've been sort of diverging. And again, what I'm pointing out is that when we match a simple energy balance model to the observations, how much the deep ocean is warmed, how much the surface has warmed, we get only about 2 degrees, maybe less, of estimated future warming from a doubling of atmospheric CO2. Okay, well, we aren't the only ones that are saying this. Nick Lewis and Judith Curry, a few years ago, published a couple of papers where they do something similar to what we did, and they get only about 1.5 degrees to 1.7 degrees C as a global average response to a doubling of atmospheric CO2. So generally speaking, those of us skeptics who analyze the data and the energy budgets and stuff like this, we come to the conclusion that these climate models are probably warming the climate system twice as much as they should be. That's our position as of right now. Now, I think there's quite a bit of deception going on with the alarmist language behind the so-called climate crisis. For instance, you'll see these news reports, which I alluded to earlier, that tend to exaggerate things, right? So, for instance, here's a news report from The Guardian. Global warming of the oceans is equivalent to an atomic bomb exploding every second. Well, that sounds dramatic, right? I mean, that's why people get alarmed. An atomic bomb every second? Well, as I mentioned, that amount of energy is tiny compared to what nature is doing. The sun is putting the equivalent of 300 atomic bombs of energy every second into the ocean. So, the Earth is a big place, and natural energy flows in and out of the Earth system are huge by comparison to what humans are doing. Now, there's other exaggerations and falsehoods and deceptions. For instance, I've got a list here. Number one, we've got hottest year or decade ever. Well, yeah, by a hundredth of a degree or so, and it's an amount that nobody can feel. In fact, I've said that anybody, living on the Earth, even if they've lived for 70 or 80 or 90 or 100 years, they have experienced such extreme temperature changes over the years that they probably can't discern global warming in their lifetime. It's just too slow. Okay, number two, wildfires are increasing. Well, in some areas, I imagine, but globally, what has been published on this subject, the global measurements are that wildfires have not increased. And regional increases like what happens in California, these are usually rooted in either forest mismanagement, not clearing the forest, letting too much undergrowth grow in these areas that have a seasonal drought. Every year, every summer, it's a drought in some areas. And then in the winter, the rains come and vegetation grows. So you've got all of this built up fuel ready to burn. And then, as people move into these rural areas, not only in California, but like Australia, you get a lot of arson and accidental fires started that nobody wants to admit to. So, there's a lot of places around the world that burn every year. And it's getting worse, but it's usually forest mismanagement and just plain stupidity or arson. Number three, storms are worsening. No, storm intensity hasn't changed from our measurements. Now, the storm financial losses continue to increase, but that goes with the fact that our infrastructure continues to increase. And here in the United States, for instance, people have been flocking to the coast for decades. And it was only 120 years ago that there was virtually nobody living in the Miami area. A few thousand people. Now the whole metroplex, Miami, Palm Beach, that whole area through there. You've got, 10 million people? I don't know. It's a huge number. Well, that comes with infrastructure and all kinds of things that any storm is going to end up damaging. So damages increase. Number four, crops are failing. No, they're not. In fact, global crop yields in terms of bushels per acre continue to break records around the world. Number five, humans are suffering. No, even though we're a little warmer now than we were 100 years ago, cold still kills far more people than heat does. There are no climate deaths. I'll be showing a graph of this in a minute. We have only 10 years left. Well, we've only had 10 years left for the past 50 years or more. I've been doing climate research for at least 30 years, and I've been hearing this only 10 years left since the first Earth Day. That was in the early 1970s. And finally, there are these groups that have taken advantage of the public worry over climate change and global warming, like the Extinction Rebellion. But, this is just craziness, because moving towards a primitive socialism is not very smart and is not being green. And I don't think the people that are part of this rebellion would actually want to live in a world that is governed by those principles. Now, on the subject of crop yields, here's crop yields showing how cereal production globally has increased even faster than population. In other words, the world is being better fed. And on this graph, you see the bottom line, that the land that's under cereal production really hasn't changed. In other words, we're producing more cereals year by year on the same amount of land. We don't even have to increase the amount of agricultural land, because the technology behind growing crops improves year after year after year. Deaths from catastrophes. Now, these are, on this graph, these were called climate-related deaths, but I don't call them they're weather-related deaths. Floods, droughts, storms, things that have always occurred. And these, deaths per year since 1920 have gone down tremendously, because as people become more affluent and take advantage of, the advances that we have now, which are partly due to access to abundant, affordable fossil fuel energy. it's gotten to the point where, we have protected ourselves from natural weather disasters. On the same subject, Roger Pilkey Jr. has, this is something he's been researching and publishing for many years, and he says that weather disasters are actually going down over time if you measure them as a proportion of the GDP. If GDP represents, how much population is producing more and more, which also includes infrastructure and buildings and housing and all of that there's actually been a slight downward trend in weather-related losses since 1990. I guess this chart begins in. The cost of renewables, wind and solar, can be useful in certain limited applications, but to provide the amount of electrical energy that the United States and the world needs requires a lot more energy than wind and solar can provide. And in Europe, since they don't hide their costs of electricity behind subsidies and such like we do, we can measure how much the cost of renewable energy is in terms of how it increases the cost of electricity. So, for instance, this graph shows for the EU nations how the temperature, or the cost of electricity in kilowatt hour, cents per kilowatt hour, or euro cents per kilowatt hour, increases depending on how much wind and solar that country depends upon. And in the case of Germany, the price has doubled over the years, and all they got in return was a 20% displacement of their electricity demand with wind and solar. Well, that's pretty darn expensive. That money could be going someplace else useful, because money not spent, money wasted in one area is not available to benefit people in other areas, for instance, healthcare or whatever. So despite the science and the observations and the economics and the worry that people have, I think these prophets that are predicting doom will continue to alarm us, because they get profits, monetary profits, which depend on alarm continuing. So who are some of these people that depend on the public being continuously worried about climate change? Well, first of all, the climate modelers. I mean, this is their business. This is what they've been doing their whole careers. And if the climate problem, the global warming problem, were to go away, then, there wouldn't be any need to fund climate models anymore, right? So those climate models, they're producing more and more warming over time. And now, I won't go into it, but the latest results from these models suggest that the actual climate sensitivity of these models is going to be about 4 degrees C, averaged over all the models. That's pretty extreme, and I don't believe it. I believe it's going to be 2 degrees or less. Secondly, the education system. Many of you with children in school know that global warming alarmism is pounded into our kids' heads every day. The news media, that goes without saying. Number 4, the entertainment industry. Been lots of weather disaster movies on TV, some of them very entertaining, that are based in the idea that humans have caused weather disasters to get worse. Number 5, obviously political leaders and government agencies, because, in order to solve this supposed problem, we obviously need politicians and government agencies to tell us what we should be doing and to collect the money from us to do those things, right? 6 is closely related to that. Government grants, programs, mandates. I mean, even my salary, half of my salary right now comes from a government grant, which wouldn't be there if it weren't for the fear of climate change. Number 7, rent seekers, just all those people who want access to political power. Number 8, an increasing number of activist corporations. We even have big oil CEOs who who claim that they think global warming is a serious problem, something needs to be done about it. Well, of course they know that the demand for fossil fuels will continue into the future. And to the extent that government makes fossil fuels more expensive, either by making them more scarce or taxing them, it's the people, it's the consumers who pay for that. It's not the oil companies. So why should they come out in favor or supporting even global warming skeptics? Because I don't get money from them and I never have. Finally, we have an increasingly frightened and guilt-ridden public. Well, for those that don't really stay informed on this issue, that spend the time because, they're just trying to make ends meet on a daily basis, they're worried about this stuff and they sort of have to go with, well, what are most of the politicians and scientists telling us? And I can understand that. They don't have time to look at it. So we have a frightened and guilt-ridden public that wants something done. So, in summary, for a climate emergency to exist and require a change in energy policy, you would have to have climate change and warming, which is well beyond what humanity is already used to. That hasn't occurred. Number two, the cause must be greenhouse gas emissions. And as far as I can tell, maybe half of the warming we've seen is due to greenhouse gas emissions, but we don't really know. This is something that's assumed by the climate models, that it's just due to increasing CO2. The cure, for instance, wind and solar energy, can't be worse, cannot cause more harm than simple adaptation. And the benefits of extra CO2 must also be taken into account. It's estimated that trillions of dollars of additional agriculture production has occurred due to an increase in CO2 in the atmosphere. That's pretty amazing. So there is no climate crisis, but there will be a humanitarian crisis if we allow the warmongers to get their way. Thank you for listening to this, and I hope you've learned something.
Welcome back. Wasn't that a great presentation? So joining us now live from Huntsville, Alabama is Dr. Roy Spencer. Good evening, sir. Welcome to the show.
Hey, Michelle. Good to be with you.
Thanks so much for that presentation. I think people will really enjoy it. Now, you were just mentioning to me that you have something special for Canadians, a temperature plot for Canada. Could you give us the lowdown on that?
Yeah, this just came up in our discussion in the last 10 seconds before we went live. And what I did today was I brought up the temperatures for Canada.
Mm-hmm.
This is surface temperature since 1950
mm-hmm.
up through 2019. And there's two plots here. The blue is the actual temperatures, and it's month to month, so the blue bump, goes up and down a lot.
He's gone.
Each normal months are below normal.
Break up. Yes.
The important thing is that while there is an upward trend in temperatures over Canada since 1948, and it's 0.24 degrees C per decade, in the last 20 years, since the year 2000, the temperature trend has been flat in Canada, while the red curve is climate models, and that shows it should have gone up close to 1 degree C.
Wow.
The average climate model says warm close to 1 degree 20 years. The associations say it hasn't warmed at all in that time.
Could you just repeat that last sentence about how it has not warmed in that time?
Right, that the climate models say that it should have warmed by almost 1 degree C in the last 20 years, averaged over Canada. But in fact, the observations show that there has been no warming in Canada in the last 20 years.
So I guess we're not warming 3 times as fast as the rest of the world, as our environment people like to say. Is that true?
Well, that's That's true even if you go back the full 70 years that I showed on that plot,
Hmm.
that the average warming trend since 1950 is 0.24 degrees C per decade in Canada.
Uh-huh.
And that's not three times that. That's not three times global. It's very close to global rate. And these aren't my temperatures. These are the official temperatures that the UN uses in their intergovernmental panel on climate change assessments of global.
Wow. Well, that kind of blows the doors off the climate emergency in Canada, doesn't it? We have
Well,
some,
it's
yes?
Well, yeah, that's part of the exaggeration I talk about in the talk that people just watched. Is, a lot of what they hear is half truths and exaggerations.
Hmm. Well, we have a lot of live questions coming in now, and I have a couple that I could ask you if you're ready to hear them.
Sure,
So
go ahead.
we have one here from Michael. To what degree is the ability of the long wave infrared to interact with carbon dioxide already saturated?
Okay, this is a good question because some people think, on our side of the issue, sort of the skeptical side of the issue, some people claim that carbon dioxide, adding carbon dioxide to the atmosphere really can't affect temperatures because the atmosphere effect, the warming effect is already saturated. But that's not true. I mean, I wish it was true because I would be using it as a point to argue. But it's not. All you have to do is yes,
I think we had a bit of breakup there. Could you just say that again?
much CO2 as the Earth does. Okay, Venus has 230,000 times as much carbon dioxide as does the Earth.
Hmm.
And the temperatures on the surface of Venus are hot enough to melt lead. Okay,
Right.
so it doesn't matter. The saturation effect of CO2, there is a partial saturation. Every time you double atmospheric CO2, you get less and less temperature effect, okay?
Hmm.
So there is sort of a semi-saturation effect, but you can keep adding CO2 more and more and more, and it'll keep adding more and more warming, but by lesser amounts, okay?
Okay. So just on that point of Venus, the World Economic Forum just issued a statement that Venus used to be like Earth, but climate change made it into what it is today. Do you have a short comment on that?
I think I think some of these people must be watching too many science fiction movies or something because that's just, I don't think there's any science behind that at all.
Okay, well, let's move on then to James' questions. So he says, is there evidence that cloud formation increases or decreases with increasing concentrations of non-water greenhouse gases? And if so, would the subsequent changes in cloud formation have a net positive or net negative radiative perturbance, shortwave and infrared, at the surface?
Okay, so translating that question, it's basically as CO2 increases, it produces, like I mentioned in my talk, this very small direct warming effect. A doubling of atmospheric CO2 on Earth should cause about 1 degree C of warming, which really wouldn't be bothersome for anyone, okay? The question is,
Mm-hmm.
how are other things in the climate system going to change in response to that little bit of warming? So the question about clouds is, are clouds going to change in such a way that they're going to amplify that warming or make the warming less? All the climate models claim that the clouds are going to change in such a way as to amplify the warming. In other words, for instance, as the climate system warms a little bit from more CO2, clouds will dissipate a little bit and let in more sunlight, which will amplify the warming. Okay, and that is the big uncertainty. That's the big uncertainty. I don't personally believe, and we've done published research on this, I don't think that cloud feedbacks are nearly as positive as these climate models claim they are. And in fact, the cloud feedbacks could be negative. And it's just surprisingly difficult, because I've worked on this for years, to tell from just observing the climate system what it does year after year after year, the variations it goes through. It's really difficult to determine what those cloud feedbacks are. And even the climate modelers admit it's a huge uncertainty, but still they believe that the feedbacks are positive and are going to amplify that little bit of warming 1 degree to more like 4 degrees.
Seems like quite a lot. I have a question here from Sandy. What government or the UN would allow Bill Gates to create man-made climate change by sun dimming over Sweden or anywhere for that matter? Do you have
Okay, so what Gates is looking at and MIT is looking at is called geoengineering, and it's sort of a way of where we could step in and counteract the effects of global warming by causing a cooling effect to counteract the warming. I don't think that's ever going to happen because I think there would be too much, changing climate, even though Mother Nature does it occasionally. The Pinatubo eruption, volcano eruption in 1991, million tons of sulfur dioxide into the stratosphere. And this is the effect they want to mimic. That, when you put stuff up there, it scatters sunlight and it dims the sunlight a little bit, maybe 15 million tons up there, which is going to be tough to do. That would take an awful lot of aircraft flights. And even if they were successful, you can reverse it because you just stop putting stuff up there and it settles out of the atmosphere within a couple of years. And then the climate system goes back to what it was doing before you put the stuff up in the stratosphere. So I'm sort of ambivalent on that. I think it's sort of a waste of time and money. And I don't think it's going to happen anyway, because I think there would be too much public outrage over it.
Well, I think it's slated for June, actually, in Sweden.
Well, from what I understand, it's just a test experiment to test the instrumentation and on their balloon. I don't think they're actually going to put a bunch of any kind of material up there yet.
Well, we just sent out a press release last week on this topic, and we included a video with, it was some kind of a forum with Alan Roebuck, and he did quite a good breakdown on the costs of doing such a thing and the risks, and he's quite concerned about it. He's quite opposed to it.
Really?
Yeah, he was surprised. He said in 2006 he ran into a group of engineers and geoscientists who were like, "Yeah, let's do this." And he said in this article, like, he was astonished that people would want to interfere purposely to make climate change when people are actually concerned about humans inadvertently making climate change from using fossil fuels. So he wrote about 20 reasons why it's a bad idea, and years later came up with 7 more. So, but it's quite interesting because he does go into quite a bit of detail about it and the costs, like sending up a plane to blow this stuff into the air. I have a couple of more questions.
I would imagine it's very expensive.
Yeah. Yeah, and for questionable benefit, and let's hope there's no lackey in the middle of it, because that could be catastrophic. So Murray asks, assuming the Canadian government achieves its Paris goals, what will be the impact on global temperatures? And I guess that's presuming that Canada is about 1.6% of the world's emissions.
Producing carbon dioxide altogether, it's going to have no measurable impact on global temperatures. If as far as the Paris Agreement goes, once Biden gets us back into the Paris Agreement, and if all the nations of the world abide by their proposed contributions, to cutting down on CO2 emissions, which is totally voluntary.
Right.
It's totally voluntary. So it was calculated years ago that if everybody abided by their commitments, all the nations of the world abided by their commitments, that the net effect on temperatures by 2100 would only be 0.2 of a degree C. Now that I can tell you, since temperature monitoring over decades, I can tell you that in the next 80 years, C is basically in the noise level. I don't know that we can even measure 0.2 of a degree change over 80 years. The measurements aren't good enough. So, abiding by Paris, excuse me, isn't going to have a measurable effect on global temperatures by 2100. Now, I fact-checked this just by coincidence yesterday, because I hadn't thought about the issue for several years since Paris went away when Trump came into office. But I looked it up, and I found a fact-checking website. Basically, it tried to debunk the idea that it would only be 0.2 of a degree C effect by 2100, the reduction in global warming. And it never actually got around to debunking it. It said that Al Gore disagreed, which coming out of Al Gore's mouth. But it mostly said that, yeah, but that 0.2 of a degree doesn't take into account that we will have even bigger cuts in the future. Well, that's a separate issue. That's not the Paris Agreement.
Yeah. Okay, well, we have a question here from Paul. Where can I find an objective compilation of facts that are accepted by the majority of scientists, be they in the catastrophic anthropogenic global warming or the denial or the neutral camps? So is there a website with objective compilation of facts?
Objective information like on the science of excuse me, of global warming, pro and con and all of that. I don't think there is. I like to think I'm more objective than most, but I'll tell you that scientists, when they're looking at imperfect with different explanation for what they see in the data, worldview. Okay, so when it comes to climate, for instance, I have found that climate scientists in particular, but especially earth scientists in general, from all different earth science disciplines, anybody that works in the field, generally speaking, thinks that the world is fragile. And that's a worldview point. Like an ecologist might say that an ecosystem is a fragile ecosystem. Well, the term is meaningless. Okay, an ecosystem is what it is. Ecosystems change all by themselves. All by themselves. Now, my worldview is that quite resilient. Yes, we have the ability to change it somewhat, but not as much as people are being told through the media from most of the climate scientists whose jobs depend upon a crisis existing. And students in school, they're all being taught this as well.
Yes, well, I think that's a very good point also about the fact that people's jobs rely on it, not even so much of the scientists, because I presume that much of their research is useful in the end, even if it may be amplified by the media. But certainly, like all these environmental groups who love to rave about the climate catastrophe, send us money and we'll help you save the planet. I find that quite despicable, actually, because they're not saving the planet. They're just taking your money, and they're not scientists, so they're not doing meaningful research either. So we have another question here from Ron. And just on the topic, Paul, of that website, you could go to friendsofscience.org. Of course, we feel we're quite objective. So Ron asks, many astro and solar physicists, including NASA, have forecasted that we're entering a grand solar minimum. Can you confirm that the IPCC, the Intergovernmental Panel on Climate Change, models, or their computer simulations, that it does not reflect that reality of the grand solar minimum? And also, could you comment on the very serious implications of a grand solar minimum when the temperature drops, which historically has led to real climate emergencies?
Well, this is where I get into trouble with my fellow skeptical friends, is I really haven't jumped on the solar forcing of climate change bandwagon. I'm not saying that it's not possible. It's entirely possible. Basically, there's two effects related to the solar cycle. Okay. One is, the solar cycle is accompanied by a change in solar output of total energy of only 1/10 of a percent. That effect is in the climate models, but it has very little effect, and we've never really been able to see the effect of the 11-year solar cycle in temperatures, say, over the last 100 to 150 years. I've looked at it. Other people have looked at it on this, even on the skeptical side, and we just don't see it. Now, the theory that the question that Ron is asking about is an indirect effect that during a solar minimum, and we're supposedly going into this grand solar minimum of solar activity with very few sunspots, that the sun isn't screening out the galactic rays that come into the Earth. All cosmic rays come in, which they've done, especially in Europe, they've done lab experiments to show that these cosmic rays can act as cloud condensation nuclei, and could lead to more cloudiness. So the grand solar minimum can lead to more cloudiness, reflecting more sunlight out to space, less sunlight to warm the Earth, and the Earth cools. So it's sort of in the realm of theory models, partly because that effect really isn't quantified. How much of a cooling effect is it? Does it really exist? Does it only occur, say, in the low cloud areas on the eastern sides of the ocean basins? In other words, is it just a low cloud effect? So it's the kind of thing that isn't known well enough. They only put in the climate models the things that are known well. Okay, and the whole CO2 theory is, in terms of its direct warming effect, is very well understood. I mean, there's thousands of lab measurements, and we even technology for monitoring temperatures from satellites. This has been going on for decades. That goes into weather forecast models that provides your daily weather forecasts. Okay, if it weren't for some of those measurements that depend on CO2 in the atmosphere to work, your weather forecast wouldn't be as good as it is. No jokes, please, because I'm a meteorologist.
Okay. So you're not forecasting or perceiving a grand solar minimum cooling in the imminent future? Or you're...
Yeah, I don't think so, but who knows? I mean, there's just so much we don't know about the climate system. So I'm not willing to reject it out of hand. I just haven't seen enough evidence to support it.
Okay. Now we have a question from Ken. He says, Dr. Roy Spencer, your previous research has shown that short-term cloud feedbacks might well be negative, which would lead to low climate sensitivity. So why can't short-term feedbacks be used to estimate the long-term cloud feedbacks?
Oh, that's a good question, and I wish I knew the answer, because that's something this is part of the holy grail of climate research.
Sorry, I think you're breaking up there. Could you just repeat that?
How much the cloud feedback problem is unsolved. His specific question is, why can't we use these short-term feedback and just assume that they have long-term? Well, maybe they do happen for long-term climate change. We just don't know. And it's just one of the many uncertain things about climate change and forecasts of global warming. And the climate modelers make it sound like all of this stuff is already known, but it isn't, because the climate models themselves for 30 years now still produce at least a factor of 3 range of global warming estimates across the models.
Wow.
They're not getting any better. They're not tying down future warming at all. It's as uncertain as it was 30 years ago.
So when you say that they're not getting better, like for people like myself, a non-scientist, do you mean that, if I'm making a climate model projection, a simulation, and I'm projecting this type of temperature rise, and then this is what's being observed, which is down here. If they're getting better, should they be closer to the observed temperature? Like, should they be running in parallel? But
okay, they should
like so?
They should have about the same warming trend over, let's say, 30 years or longer. Okay, and the longer the period of time, the closer the warming trends should be. Climate model simulation to the observations.
Okay. All right.
The range of
Sorry, you broke up there. What was that?
Can you hear me?
Yes, but you just broke up on that.
Okay, range of three in range of three in uncertainty in the climate models I was talking about has to do with the fact that the newest climate models that are coming out now range from like close to 2 degrees C of warming, 1.5 to 2, about like 1.8 on the low end for a doubling of atmospheric CO2, up to about 4.5 or 5 degrees, or even more. So there's a huge disagreement between the models of how much warming there will be. And that disagreement has been the same for the last 30 years.
So it's really looking through a crystal ball. Might as well get out the tarot cards. Okay, so we have another question here from Jim. How do you respond to the claims by groups like Extinction Rebellion and people like Greta Thunberg who say that they have the science on their side? And how do you respond to those who dismiss you as a denier and not part of the 97% consensus?
Well, when people say things like that, it's mostly hand waving. What do they mean by science? When that paper years ago came out that talked about this 97% consensus among scientists, I read through the paper and I realized, hey, I'm part of the 97% consensus, because it basically was just that, almost all scientists agree that it has warmed and that most of the warming is due to humans. Well, I I agree with that. I agree that it's warmed, and I probably most warming is due to humans. But that doesn't mean it's an emergency. You have to start talking about numbers.
Ah.
You have to talk about real numbers, not hand waving.
Okay. All right. And so we have another question here. Dr. Spencer, you stated that warming will be largest at high northern latitudes. Could you please explain why this is so, especially for us because we're in Canada and so much of us is an Arctic area. This is particularly relevant to us in Canada as the green environmentalists keep shouting that Canada is warming 2 to 3 times faster than the global average to support the claim that we have a climate emergency. And of course, the graphing that you showed off the top blows that theory out of the water. But why is it that warming is largest or will be largest at northern latitudes?
And over the earth, okay? The land will warm much faster than the oceans, okay? Because the ocean, and there's ocean currents, there's vertical mixing, and if you warm the surface, a lot of it just gets mixed down, and most of the oceans are even in the tropics, most of the depth of the oceans are about 40 degrees Fahrenheit, a few degrees above. So the oceans warm very, very slow for the same amount of input of energy compared to the land. The land warms very fast. The land distribution, most of the land on Earth is in the northern hemisphere. There isn't that much in the southern hemisphere.
Right, and the bottom is all ocean.
And that's the reason why. And that's why you see more warming at high northern latitudes, and then when you go to high southern latitudes, you get the least amount of warming. It's just the distribution of land across the surface of the Earth.
Okay, and you said something very interesting the other day when we were just doing a test. You were talking about the Arctic and how that region, the land can get to like plus 80 degrees Fahrenheit in summer, and yet you were talking about the sea ice and how the ocean, the Arctic Ocean and the sea ice actually stay at a very cool temperature. Could you just explain about that again?
Okay, the reason we were talking about that is because these thermometer data sets that try to average temperature, the thermometer distribution across the Earth is pretty thin. It's pretty sparse. We have a lot of thermometers in the United States, okay, is largely uninhabited. So you have got a lot fewer thermometers in Canada than we have in the United States. And then, of course, the oceans, you have almost no thermometers that go back, say, 100 years. So what they have to do when they try to make these thermometer temperature data sets for the world is they say, okay, I'm going to assume that this one thermometer is influenced, let's say, 1,000 kilometers in all directions. in some areas that works. Okay, in some areas that works. But what we talked about is when you get up on the edge of the Arctic, let's say you're up on the Siberian coast, on the edge of the Arctic Ocean, you can't take a temperature in Siberia in the summer, which is it's actually warm up there. Gets to the 80s or 90 degrees Fahrenheit, in the 30s degrees Celsius, up there in the summertime. But once you get out over the Arctic Ocean, that water is so cold, it seldom gets above 0 degrees C, or a little above 0 degrees C. You can't extend those temperatures from warm land out over to an ocean that's still partially ice covered, or the ice had just melted.
Right. Okay. All right. So we have another question here. Could you please elaborate on why the climate change and warming must be well beyond what humanity is already used to, and that the cures, such as wind and solar, cannot cause more harm than simple adaptation? What's the best estimate of the cost of climate adaptation that you know of?
Well, this is something that Bjorn Lomborg, the Danish, let's see, what is he? Is he economist?
Yes, he's an economist.
Well, but he wrote that book many years ago called The Skeptical Environmentalist.
Yes.
Yes. And he brought together many years ago, he brought together a whole bunch of economists from around the world, including some Nobel laureates, and they all came out with the Copenhagen Consensus. Is that what
I think
it was?
Yep.
Which basically said, even if you believe these climate model forecasts of global warming, as far as humanity is concerned, it's better to adapt to the warming rather than try to fight it until we have some alternative form of energy that's as abundant and affordable as it's going to exacerbate poverty. And the leading cause of death in the world is poverty.
Right.
So to the extent we can help people lift themselves out of poverty, that's the moral thing to do, and that's what fossil fuels do. It's the moral choice for the time being, anyway.
And on that topic of fossil fuels, we should just reiterate here, as in your bio, that all of your work has been funded by the U.S. government, by NASA, NOAA, the Department of Energy, and you have never been asked to provide any service for a big oil company, and not even Exxon Mobil. Is that correct?
Right. Yeah. I mean, sometimes I wish I was, because everybody just assumes that I am paid by them.
Right. Right. Yes.
Some of the CEOs of these petroleum companies are
they're what?
Some of these CEOs now are coming out in favor of the green position. Okay. They realize that it's not popular to defend fossil fuels. And so they come out and say, yeah, we need to get away from fossil fuels, even though, I run a petroleum company. We'll gradually get away from fossil fuels. And we will, but they can say whatever they want because humanity still needs what they produce, right? So why should they take the heat for you? So they don't, as far as I don't know of any skeptic who gets fossil fuel money right now. Many years ago, a couple did for a short period of time, but our funding paled back then. Their funding paled in comparison to what environmental organizations get.
Right.
Environmental organizations get 100 times as much money as any skeptics ever got from a petroleum company.
Yes, and actually, I'd have to say that I would say most of the big oil companies are being influenced by institutional investors who are signatory to the UNPRI, the United Nations Principle for Responsible Investment, whose guru on investment is Al Gore. So that's probably where it's coming from, because they want to keep their institutional investors. So why not play the green game? You get a raise as a CEO. You get to put up a wind farm. It costs you $100 million. That's nothing in the world of big oil. And you get subsidies. You get to look green. Everybody loves you and they applaud you. And people are carbon duped. Now, we have another question here from Graydon. Does climate modeling incorporate the Navier-Stokes equations? And or just how important are these equations to ensure modeling predictions are trustworthy? And how critical are the Navier-Stokes equations for climate modeling to ensure any degree of prediction accuracy? And I think you should start with discussing what Navier-Stokes is.
Well, it's basically the most formal form of the physics equations that describe fluid motions. And basically, yes, they are, to put it in very simple terms, basically they are in the climate models. The climate models have the relevant dynamical equations that govern the motions of the atmosphere. In weather forecast models, okay? Where you're wondering what is the weather going to be like, in Calgary 2 days from now, so you have to know what the dynamics are. When it comes to climate, it's global average climate, the atmospheric motions sort of all cancel out in the end. It's kind of hard to put in a nutshell in terms of answering the questions. I mean, obviously, atmospheric motions are important for the climate system because air rising up creates clouds, which offers the sunshade that helps cool the earth naturally. So it's still important for climate. So the bottom line is yes. I don't think that's models. That's really what he's getting at. There aren't shortcomings in the climate models related to the Navier-Stokes equations. The shortcomings are related to clouds, the cycle, and how those things feed back on this little tiny bit of direct warming from the CO2. That's where the big uncertainty is. There's also another sort of uncertainty about how fast this heat gets mixed down into the ocean. That's something we haven't talked about in any of these questions, but I did discuss in the
presentation.
The reason why the oceans can be so potentially important is I mentioned earlier that most of the mass of the oceans is at a very low temperature, only a few degrees Celsius. The warmth that you think about of the tropical oceans does not extend very deep at all. The oceans have been filled up over thousands of years by water that's been chilled near the poles and then slowly sinks and fills up the ocean with cold water. Now, what does that mean in terms of climate change? The oceans are constantly overturning very slowly, okay? And there's natural variations in how fast there's vertical mixing and turning of the warm waters on top with most of the ocean, which is very cold, okay? Down deep. During an El Nino, that mixing slows down, and so the surface warms up and we get a warm year globally from El Nino. During La Nina, the opposite happens. There's more vertical mixing, and you get more of that cold water coming up to the surface. The deep cold water comes up to the surface and cools the earth for a year or two during La Nina. We're in a La Nina now, okay? Now, what happens if there are long-term changes in the circulation on the time scale of 100 years, 500 years, 1,000 years? As I mentioned in the presentation, we have evidence, and I just saw new evidence being published recently of a tree, that they found where in the Alps, where a glacier is receding and it's revealing, tree stumps that are 10,000 years old. Well, that means ago there wasn't a glacier there. It was warm enough to have a warm climate, or to have a full forest, to have a forest growing there. Same thing with the Mendenhall Glacier. Just up the coast from you, up in Alaska. The Mendenhall Glacier is receding and it's uncovering a forest of tree stumps that grew only 1,000 years ago. Now, it's entirely possible that warmth, say 1,000 years ago during the medieval warm period, let's take that as an example. It's entirely possible that was a result of just a small change in ocean circulation. Because how fast the ocean does this vertical mixing and overturning and all of that, how fast that occurs will determine how warm it gets where we live at the surface, okay?
Right.
Well, how could that happen? The climate system is what we call a nonlinear dynamical system. It's chaotic. It goes through changes all by itself. A chaotic system can go through changes all by itself without any forcing. You don't have to have the sun to change. You don't have to have increasing CO2. You don't have to have anything like that. It does it by itself. That's the nature of a chaotic system.
Well, we have a couple of papers posted on our blog, courtesy of Professor Wis Yim, who's done a lot of work on subliminal volcanic and geothermal activity. And he's found that these, big volcanic eruptions that are way down deep under the ocean, of course, they warm certain parts of the ocean, and then that hot blob moves here or there and causes changes in whatever is proximate to it. So it's quite interesting research, and it's something that I think is left right out of the climate conversation. Of course, I'm a layperson, but I found it quite interesting to read it. We have a couple more questions. Darwin asks,
Okay.
the Vostok ice core samples have shown that CO2 rise lagged temperature rise by hundreds of years, time and time again. Alarmists argue that this may have been the case in the Antarctic, but was the opposite elsewhere, particularly in the Northern Hemisphere. What is the truth of the matter?
Well, what he says is true about Antarctica, that it does seem like whatever caused temperature change then caused the CO2 to change, which sort of makes sense. If the Earth warmed, you'd have more life. Okay, right? In the tropics, it's the warmest, and that's where the most life is. You go up to the tundra, and there's very little life, and it's cold. So if you get global warming due to whatever the cause is, you're going to have more life, more CO2 is being cycled through the ecosystems because life depends on CO2. The vegetation on the land, the plankton in the ocean, it's all the beginning of the food chain for all life on Earth. So CO2 is the gas of life. Okay. So the question is, what he's getting at is, if CO2 lags temperature in Antarctica, okay, when you go back thousands of years in these ice cores, doesn't that show that lagging temperature now? Well, no, you can still have, we know we're producing CO2 at double the rate needed to explain the atmospheric rise, okay? Some people on my side of this issue think that most of the CO2 increase is natural, and I just don't see how that's possible. Like I said, we know pretty much how much CO2 humanity is producing from the burning of fossil fuels. We know that. Put that into a simple model, you can replicate what the rise of the CO2 year after year since 1958, when we started monitoring atmospheric CO2. Like I said, we produce twice as much as what is necessary to produce the observed rise in atmospheric CO2. So while it's true that if you warm the oceans, there's an outgassing of CO2, okay, there are so many other things going on. That effect is buried in the noise. So I'm quite sure that virtually all of the CO2 rise that we've observed is due to humans. But this is another thing you don't hear much about. What you don't hear is that the CO2 rise the system is taking out the extra CO2 we put in the atmosphere at a pretty good clip. In other words, as we add more and more to the atmosphere, life takes more and more out of the atmosphere. And for instance, Craig Idso, who has hundreds of peer-reviewed publications on his website, co2science.org, I think, patients show that virtually all types of vegetation benefit from more CO2 in the atmosphere.
Right.
And he estimates that global agricultural productivity has gone up by trillions of dollars since 1960, just because of more CO2 in the atmosphere. It's a fertilizer. It makes plants more water efficient. It makes plants more drought tolerant. More CO2 is it's one of the benefits that nobody ever talks about. You're not allowed to talk about it.
Right. No, it's a satanic gas. and we're all
Yes,
going to
yes,
be burned at the stake
satanic
for it.
dance.
That's Dr. Kandakar's phrase. Sandy asks, do you think there's a danger level of how many ppm of CO2 would be in the atmosphere, like 800 or 1200?
Well, I suppose the more you added, the
Excuse
bigger
me.
risk it would be, right?
Mm-hmm.
But the last time I looked at this, I'm not convinced to reach a doubling of atmospheric CO2. Which is, the pre-industrial CO2 concentration is, we're not sure, but we think it's something like 275 parts per million before we started producing, burning a lot of stuff. Okay.
Mm-hmm.
So then you got to get to what is that 560 parts per million to get doubling of CO2. I'm not sure that we're going to. I think there's going to be alternative energy technologies for one. Number two, I think that the system is pulling CO2 out that as we slow down our production of CO2 in the coming decades, and the slowdown isn't going to really occur probably for a few decades. At some point, the biosphere is going to be taking it out just as fast as we're putting it in.
Mm-hmm.
And then at that point it stops rising. So I don't worry about us reaching 800 or 900 parts per million. I don't think that's going to happen.
Okay, we have another question here from Jono. We're being told that a major mass extinction is now underway of animals and biodiversity. Can this be squared with 1 to 2 degrees Celsius warming?
Well, I'm not an expert in biodiversity and extinction, but from what I've read, it sounds like that's an area that's exaggerated even more than global warming. That there really hasn't been these mass extinctions. I mean, to some extent, species go extinct anyway, processes. But I don't think there is convincing evidence that there's any kind of mass extinction of species going on. But I'm not an expert. It'd be better to ask somebody else.
Question from Matt. Excuse me. In the Canadian university world, anyone giving a speech like you just did would be at risk of losing their job or funding. Do you run that risk?
Well, I'm in Alabama, so that's one of the safer states in the United States to be doing what we're doing. But I will say that in the last 30 years that John Christie and I have been producing the global temperature data set from satellites, we've been getting more and more pushback from, for instance, the media in Alabama. And we've had a little bit of pressure.
You've had a little bit of what? Sorry.
Try to get,
Could you repeat that?
we've gotten a little bit of pressure from we're getting a little bit of pressure from the university system in Alabama, but not much at all. That we could use maybe hire someone that can counter us.
Well, I don't know if you've seen Donna's presentation, but it's pretty shocking. They shut down.
Yes.
Yeah.
And I think this is going to get worse. We're going to see more of this during the Biden administration.
Okay. Yes. Yeah, we have a similar question here. Do you fear for your career, your safety, or personal freedom as a result of the new U.S. administration, given its apparent hostility toward climate deniers and skeptics?
A little bit, yes. I think it's going to be more censoring of the government system. And several years ago, our building was shot up by somebody with a gun in the middle of the night. It was like the day after one of those the Earth First, not what was it, Earth Day parade or something. Somebody got up and shoot up the windows around John Christie's office. That person was never caught. But it goes with the territory, I guess.
Yeah, it's a shame because really it's such an important issue. And one of the things we advocate for is open civil debate. So we're very glad that you could come on the show and express your views, and hopefully other people will learn from them and ask their own questions, and maybe take a second look at some of the scientific research they've been reviewing, and see how it jibes with their views. Now, Greg is saying Ross McKittrick and Steve McIntyre did a very thorough job of debunking Michael Mann's hockey stick graph in the early 2000s. But recently, Greg has seen a number of posts on various sites by people claiming that similar hockey stick type of results have been duplicated in several other independent studies and are therefore valid. Are you aware of those studies? And if so, are you able to comment on them, and do they have any more solid foundations than the original work of Mann?
Uh, not in that area, so I can't comment on it.
Okay, that's fair. So one of the questions that I have is, how do you know, what is your best means of addressing a person like myself, a non-scientist? What example do you tend to use most frequently when talking to someone and trying to help them understand that it's not a climate emergency, trying to calm them down?
Well, there's all kinds of things, and I alluded to some of them in the presentation. One is that we often hear about severe weather. For years now, it's been common for the media to claim that severe weather events have something to do with climate change. Yet there is no evidence observationally from our meteorological data that severe weather has gotten any worse. There's large variations in severe weather occurrences, that's for sure. So you can cherry pick a period of time and get a decrease or an increase in some kind of severe weather event, and that's sometimes what you hear is cherry picking of the data.
Mm-hmm.
So that's severe weather. One of the things I like to point out is that, and this was in the presentation, the energy imbalance that is causing, okay,
Mm-hmm.
is so small, we don't know any of the natural energy flows accurately enough to rule that Mother Nature is responsible for most of the warming. Now, I think CO2 is responsible for some of it. I'm guessing probably more than half, but we don't know. There's a huge amount of uncertainty, and people that claim that they're certain, they're about CO2 causing, being the only cause of warming. They're so certain of it. That's a statement of faith. You cannot show it based on science. Okay. They blame it on CO2 because that's the only thing they can think of right now. And when I've argued with them about it, they say, but what else could it be? Well, I don't know. Cancers don't we have cancers that we still don't know what causes them?
Right.
Right?
Yeah.
It doesn't necessarily mean that it's from all the remaining cancers that that occur that we don't have an explanation for. It doesn't mean they're all caused by your cell phone.
Right.
It could be there's other things going on.
Exactly. Yeah. Yeah, actually, the only reason why they think of carbon tax, carbon dioxide, is that it's one thing that you can tax. You can't tax the sun, you can't tax the oceans. So, that's why it's become the predominant narrative, and I presume that that's why it's part of the United Nations Principles for Responsible Investment, the institutional investors, the Black Rocks, and all the climate funds. This is the foundation principle.
Well, one of the for those of us old enough to remember the ozone depletion issue, right? That the ozone layer was being destroyed by our use of Freon, okay? Well, one of the main people involved in getting the Montreal Protocol of 1973 passed, to ban the production of chlorofluorocarbons was Bob Watson. Okay, I think he's from Oxford. He became a NASA scientist, and then he went to the White House to work with Al Gore.
Oh.
And we went to visit him in the early 1990s. John Christie and I went to visit him. And he was fresh off the success of the whole Montreal Protocol and Freon ban and all of that. And I still remember him saying, we already banned Freon, CO2 is next. Now, this is back when
Wow.
they were just getting started with the UN IPCC to study the issue.
Mm-hmm.
But from his wording, it was clear to me that they were a policy goal, a long-term policy goal in mind to regulate the production of CO2, and that they were going to put together whatever scientific evidence they needed to support that goal. And that's what the IPCC does. If you don't play as a scientist with them, you don't get to play in their sandbox. You have to, their consensus is manufactured, because only those people that agree with the consensus get funding and get to be on the research committees that support the UN IPCC.
Right. Well, and this all goes back also to Enron, because they made a bundle on the SO2 emissions trading program during the coal, well, not really coal phase out, but during the institution of filtration on SO2. And so they wanted to apply that to carbon dioxide because it's a gas that's everywhere, even better than SO2, which is only from certain industrial context. And McKinsey was deeply involved in that as well. So, and McKinsey is the world's leading management consultant, and they've been deeply involved with climate works as well. So, as you had said, this idea of banning carbon dioxide, which would kill us all, by the way, I guess is kind of the fundamental premise of all of these things. We have a question here from Stephanie. And she's saying, I'm worried that if we're killing our economy for controlling CO2, when nitrogen oxide and methane are still being released, especially all the fugitive emission stuff is effectively on hold, and most oil and gas have suspended their programs other than a couple of the big guys. What do we do? How do we communicate effectively? Because, of course, the Canadian economy is highly, especially Alberta, highly dependent on oil and gas, as are most economies of the world, but we're really getting slaughtered here.
Well, I'm not sure what kind of environmental regulations you have for certain kinds of pollutants in Canada versus what we have here in the United States. So the EPA in the United States is pretty strict about all kinds of things. They've tightened down emissions on just about anything that could conceivably be dangerous. And one of the things I try to point out to people is, at some point you're hurting yourself by trying to make things too clean. I mean, right. You can't, if you spent all the time and money it took to clean out, or let's say remove all the bacteria in your house continuously, you'd go possible, right? Yeah. You make things fairly clean and then you live with the rest, right? Because otherwise you're putting money into something that doesn't have as much benefit as if you put the money into something else, like food, healthcare, things that are kind of necessary to live. Yeah. So I'm not sure exactly what she's talking about. I assume it's a Canada issue. I just know that here in the United States, everything is regulated if it has any potential of having, any negative impact on humans, and the EPA really doesn't how much it costs the economy. That's changing with the Trump EPA, but it may change back again.
Right. Well, we're highly regulated here in Canada, and I think we have 600 different pieces of legislation at federal, provincial, and municipal levels related to greenhouse gas emissions management or incentives to be cleaner. 600. So kind of burdensome. And they're putting more on all the time. So we have another question here from Ron. Carbon dioxide's equilibrium climate sensitivity is very important to the whole discussion, and it's not settled science. You note that the estimate is likely around 1 degree C, which would give that roughly 40% CO2 contribution to the warming that you mentioned. I agree that with that assessment, that's Ron saying that, based on historical data. But there are proponents, for example, William Happer, who say that CO2 absorption band is becoming saturated and CO2's warming will be greatly reduced going forward. Could you comment on that scenario?
Well, I've talked to Will Happer about this. He knows a lot about the theory behind carbon dioxide absorption. Okay, and he worked on this for a few years recently, and they have a paper out on the web describing the results. And I had heard that was claiming, or other people were claiming, his work showed that the CO2 warming effect wasn't nearly as big as what climate models assume. So I looked at his paper to see that conclusion, and I contacted him, and he said, "Yeah, you're right." He says we get basically the same number for how much energy imbalance. Remember my talk. Temperature change is related to energy imbalance. If there's an imbalance between energy coming in versus energy going out, then you have a temperature change. Well, increasing CO2 reduces the rate at which the energy can escape to outer space. So you get sort of this trapping. It's not really trapping, but that's one way to describe it in words. You increase the CO2, let's say you double CO2, you get a certain watts per square meter of, reduction in cooling of the Earth to outer space. Okay. And I looked at his table, and he got basically the same number as other investigators got. I said, "Why are people saying that that your paper shows that the CO2 effect isn't as big?" And he said, "Well, you're right. The direct effect isn't." The discussion went into the feedbacks. That's where the uncertainty is. So it's a case two theory. The direct effect, the direct warming effect. If nothing else changed in the climate system, and you just doubled CO2, how much would it warm? If nothing else changed, sea ice didn't change, clouds didn't change, vegetation didn't change, nothing changed. Just add CO2, how much would it warm? It'd be about 1 degree C. All the extra warming that's dangerous is from feedbacks. That's what's uncertain. And I think what Will Happer is saying is he believes the feedbacks are, negative, but we don't know that. I think that the feedbacks are maybe slightly positive, maybe neutral. So philosophically, he and I agree, but I think maybe his paper is being misrepresented.
I see. Now, on that topic, though, of the feedbacks, would you say then that, say, the PIX group out of Germany, the Potsdam Institute, they've issued that paper on planetary boundaries, and it shows the Earth kind of like a bowling ball rolling down the down the alley and then falling into the gutter, and we're all gonna burn up and die. So would you say that's where they're using those feedbacks and claiming that they'll be catastrophic?
I'm familiar with the jury, okay, but that's all it could be. All of the claims that we're headed towards some sort of climate catastrophe entirely depend on feedbacks in the climate system being strongly positive.
Okay.
Okay.
All right. Okay, so we have another question here from Bernard, and he says, are the long-term ocean currents changing, and is this because of the effects of some global warming?
Well, as I mentioned earlier, I think it's possible for global currents to change all by themselves now, and that can cause global warming or global cooling. Now, if we do see a change in currents, what the consensus scientists will say is, oh, well, that must be because of global warming. You see, in the mind of alarmists, of climate alarmists, scientists who believe that climate change is a serious issue, they think that CO2 governs everything, that the increasing CO2 causes warming, and then that changes everything.
Right.
The ocean currents change, the glaciers change, and everything. Of course, every change is bad, right? I mean, by definition, all the changes are bad, but everything extends from the temperature change. It's a cause versus effect issue. Is a temperature change causing the ocean currents to change, or are the ocean currents changing, causing the temperature to change?
Right.
We have the same problem with diagnosing cloud feedback. When you see a decrease in clouds and warming, did the decrease in clouds cause the warming, or did the warming cause the decrease in clouds?
Right.
I wrote a whole book on this called The Great Global Warming Blunder.
Right.
And I addressed that issue, that the causation, the direction of causation, can totally change your interpretation of whether the climate system is very sensitive to more CO2 or really doesn't care about how much CO2 you put in the atmosphere.
Very interesting. Now, while we're on the topic of your books, you have quite a few books, don't you? Do you want to just list them off for us? And
Oh, wow. Well, at age 65, I don't think my memory's good enough. The first one, the one that was most popular because Rush Limbaugh advertised it on it was Climate Confusion. That's been over 10 years ago. That was my.
Sorry, can you say that again?
It has quite a bit of humor in it.
Okay.
Climate Confusion, over 10 years ago, all of it's on.
Right.
And it has quite a bit of humor in it. And then my next book, I think, was The Great Global Warming Blunder, which is more technical. Recently, one of my better books, I think, is, and recently I've just been doing ebooks. You know, they're inexpensive on Amazon that you download, and you can read it on your browser. You don't need a Kindle. Is with my most recent one is about skepticism. It's just putting skepticism into simple terms. Support the skeptics' view that there isn't a climate crisis.
Okay. And didn't you also do one on the hurricanes?
Yes. Yeah. I think that one was called Inevitable Disaster. That's a Kindle ebook, and it was basically pointing out that there's evidence that we've had much worse hurricanes in past centuries, and it went through the history of landfalling hurricanes in the United States ever since the Massachusetts Bay Colony was established in the early 1600s. Yeah, there were some amazing hurricanes that occurred that we haven't seen the likes of since. So it was in response to, well, we went 10 years without a major hurricane strike in the United States, which had never happened before, as far as we know. And then when the hurricanes return, since people haven't really seen much in the way of hurricane strikes for 10 years, they think, oh my God, it's terrible. Everything is going, the bowling ball is rolling down the German hill, right? We're all going to die. But if you look at the history of global hurricane activity, it's a lot of decade to decade, year to year variability, and there's no clear trends. And in the ocean, the variability is even greater. Like we had a big hurricane year this year in the Atlantic. Okay, sort of record in terms of number of named storms, which is another issue that some of us have trouble with, is how many storms now that they actually assign names to. But it's been virtually dead in the Pacific. Okay, so again, when you look at the global average, it turns out to be not an exceptional year for hurricane activity last year.
Okay, well, we have another question here from Stephen. The definition of the word severe when describing weather has increased due to the increased population density and the degree of personal damages. Is it simple as that? Yes?
Okay, so I think what he's getting at is the fact that there's an increase in severe weather damage, for instance, in the United States. It's very clear. But we have meteorological measurements that show it isn't because of an increase in severe weather. It's because of the increase in infrastructure that has been built, especially along the coasts of the United States, which puts, much more infrastructure at risk whenever there is a severe weather event. For instance, Miami, the Miami, metroplex down there, Palm Beach, that whole area, people live there now. Miami was incorporated as a town a little over 100 years ago. Virtually no one lived there. Nobody wanted to live in Florida. 100 years ago, nobody wanted to live in Florida. If you don't have air conditioning, it's not where you choose. So now you've got all this population that's sensitive to severe weather events, which have always occurred, and so damages go up with time. This is something that Roger Pilkey Jr. out at the University of Colorado, I believe, has been working on a lot. And just look up Roger Pilkey Jr.'s name on the internet, and you'll find some of his statements. And he considers himself an environmentalist, but he tries to be honest about severe weather effects of climate change. There just isn't any severe weather imprint of climate change yet.
Yes, I think his book is called Disasters and Climate Change, and at the rightful place of science. And at one point, he was offering one of those books for free as a PDF to journalists. And so I took advantage of his offer, and it's a great book. But I bet you all the high profile journalists did not. I mean, I know they did not, or if they did, they didn't use his information, because it certainly is a great way to calm public fears when you read the information in his book. He's very grounded, very down to earth. The facts are all there, and it would be great if more journalists would read his material. We have another question here from Ron. If humanity consumed all its oil, gas, and coal reserves, the atmospheric CO2 levels would rise to the 1600 ppm level. Based on historical theoretical CO2 climate sensitivities of about 1 degree C, that would limit the temperature rise to roughly 2 degrees C, which would neither be dangerous or unprecedented. Could you comment on that perspective?
Well, I don't know about the numbers, but the I think is good. And the bottom line is that there's sort of two components to how much warming we're going to see in the future, or maybe three. One is how fast is CO2 going to rise in the atmosphere? I think it's going to rise slower than they expect because the biosphere is going to continue to take it out more rapidly than they think. So the CO2 level won't get that high. The second thing is that produce, right? So if you used up most of the fossil fuels, of course, we'd never use them all up because at some too expensive to extract them, right? I mean, once there's almost none left, it gets more and more expensive to extract a scarce resource than it is an abundant resource, right? So we'll never run out of fossil fuels. We'll just make a financial decision that they're not worth going after anymore because we have other alternatives that are cheaper. So there's the issue, and then there's the issue of climate sensitivity. So, how much warming do you get from a certain amount of increase? And there's how much is CO2 going to rise in the future? And I think both of those things are less than what people are saying. For instance, a lot of the scare over global warming in recent decades has been because a CO2 scenario was called the 8.5, that by 2100, we would have 8.5 watts of extra trapping of infrared radiation because China was going to entirely depend on coal and all of that. But what they didn't anticipate is fracking. And that now, even without any CO2 regulations, energy generation, electricity generation has voluntarily switched from coal to natural gas, which is less polluting because it was cheaper. So that extreme scenario that produced the most warming is sort of the basis for most of what people hear in terms of future warming. So these future warming scenarios that are so scary are based on a CO2 trajectory going up, in the coming, let's say 50 to 100 years. That's totally false. We know it's not going to happen. And yet a lot of the
Hang on. Sorry, Dr. Spencer, we're having a technical problem. Sorry? Okay, we're just calling Dr. Spencer back. We lost the feed. Hi, sorry about that. We lost the feed. So you were talking about the RCP 8.5, and also Roger Pielke Jr. and Justin Ritchie have just issued a paper on that called Distorting Climate Science, the Use and Misuse and Abuse of the RCP 8.5, I think it's called.
Oh, okay. All right. Good.
Yeah, and it's a very good paper. And we have a video on our website where I happened to be at the University of Calgary when Dr. Catherine Hayhoe was here presenting. And it was quite interesting because, of course, at the time I was not aware of this issue with the RCP 8.5. But she actually does a stand-up presentation saying, see, we're headed toward this trajectory, you know, but ironically, she says, thanks to China, we're actually going to go down because they've installed so many renewables, and she points to the RCP 4.5. And PLK and the author of that report, Van Vuren, 2011, they both make it quite clear that these RCP scenarios were never ever meant to be used as a comparison like this. They're used for the modelers to try and assess what factors drive climate change, and they were never meant to be comparative pathways. But if you look at the Environment Canada report, Canada's Changing Climate Report 2019, you'll find these comparisons littered throughout the report. And, you know, like you say, the scariest and the least scariest. And one thing that's very scary about the use of these RCPs is that some of them have 3 billion less population. That's one of the factors that they reduced, suggesting to me that this is why there are people who are so keen on depopulation, because they see it as a way of, you know, of stopping climate change. But it also means you're going to have to take out a lot of people, and that's, you know, a very sick and dangerous and unnecessary thing to do. But enough of me, back to you. We have a question here from Jim. I thought your graph showing the Europe electricity price versus installed wind and solar capacity was very powerful. There is a lot of empirical evidence and papers written with the same message that wind and solar are not the answer. What's it going to take to get the frightened and guilt-ridden public and our governments to understand this?
Well, I'm not real hopeful because I don't think they really care about what's best for some. There's too much money involved in this, political power, and I don't have a. You know, truth is not going to win out in this debate. At least not in my lifetime. Sorry to sound cynical. It's going to take people standing up and saying, "This is stupid," and broadcasting that people are standing up and saying this is stupid, right? At least here in the United States, we're going in the opposite direction. We're shutting down opposing voices now. That's going to be the new administration's policy.
That's what's happening in Canada as well. We have our present administration is coming up with ways to censor and delete social media information that's deemed to be disinformation. And we've already been censored several times by Facebook. But, you know, we press on with our story. We have one final question here, and that is, can we get a link to your Canada temperature graph? And maybe you could send us that material. We can post it on our blog, or maybe we can put it up on the same website so people can refer to it. Would you be so kind as to do that? Yes.
The temperature update.
The material that you showed us at the
that we do it,
and also the material that you showed us at the very beginning. The Canada graph.
Okay. So tell you what I'm going to do. I am going to do a blog post on this graph. Okay. Mm-hmm. Here's the graph. Okay, and I'll describe what's in it because apparently it's a little too much to describe using this Skype. But basically, I thought it would be worth a blog post. So what I will do is in the next 2 days, I will post it at drroyspencer.com. And then, anyone is free to copy anything I put on my blog, drroyspencer.com, and repost it elsewhere. They don't have to ask me.
Okay, very good. Thank you so much. So we're going to wrap up. I want to thank you so much for all the time and energy that you've put into helping us put this show together, and all your time this evening and your answers to the questions. And I think that our viewing audience really enjoyed it, and I'm sure that we'll get many more comments over the next few days and weeks. And I hope that one day we will be able to host you here in person in Calgary at our beautiful Red and White Club with our buffet dinner. And I hope that one day we'll all be able to go back to normal again and have a wonderful in-person event. But in the meantime, your online presence has been very much appreciated. Thank you so much, Dr. Spencer.
No, you're welcome, Michelle.
Okay, so good night, Dr. Spencer. And to our viewing audience, thank you so much for being with us. Please keep in touch with us. Keep your ears and eyes open, because we're planning to do a series of climate science online events like this, hoping to bring together a selection of people. We've got some arrangements in process with the Clintel group of 900 scientists from around the world, scientists and scholars, all of whom say there's no climate emergency. And you can see the Clintel work on clintel.org. And we'd be very happy to have people send in suggestions for who they'd like to have us talk with on our online series. So I'm going to wrap up this evening. I thank you very, very much. Anyone who wants to see this program can buy a ticket and can screen it. If you want to buy a membership or give a gift of a membership to someone, you'll have access to this and all of our other online events. So I thank you all very much for being with us. Thanks very much to our technical team here in the studio and online elsewhere in the city. And thanks again to Dr. Roy Spencer. May everyone have a great 2021. Happy New Year and all the best to all of you. Thank you. For Friends of Science Society, I'm Michelle Stirling.